This is section 3.3, power functions and polynomial functions. Today we're going to focus more on polynomial functions. So we are going to start with intercepts of polynomial functions. So to find an x-intercept, we need to know x when y is equal to 0, and the most common way that we're going to do that is by factoring. So you factor the polynomial and set each piece equal to 0 to find x. To find a y-intercept, you're going to find y when x equals 0. So this one's the easier one. All you have to do is plug in 0 for x and find y. So let's find the intercepts of each function. The first function is given to us in factored form, which is really easy for us. So we're just going to put x minus 2 equals 0, x plus 1 equals 0, and x minus 4 equals 0. That tells me that x is equal to 2, x is equal to negative 1, and x is equal to 4. So these are our x-intercepts. To find our y-intercept, we find y when x is equal to 0. So y equals 0 minus 2 times 0 plus 1 times 0 minus 4. So we have negative 2 times 1 times negative 4, which is 8. So our y-intercept is positive 8. All right, the next one. We don't have it factored, so we need to factor. So remember, we have to find factors of negative 45 that add up to negative 4. So this factors down to x squared minus 9 and x squared plus 5. Because negative 9 plus 5 gives us that negative 4. Notice that it's an x squared because we have an x to the 4th here, and x squared times x squared is x to the 4th. To find our x-intercepts, we take x squared minus 9, set it equal to 0. Same thing with x squared plus 5. When I start solving, over here I will get x squared equals 9, so x is equal to plus or minus 3. And over here, I subtract 5 from both sides. So x squared equals negative 5. Remember, we can't have a real number squared equal negative, so we're just going to forget about that. So our x-intercepts are positive and negative 3. Then to find our y-intercept, we go back to our original and plug in 0 for x, which, easy enough, we just end up getting negative 45. For the third one, I'll let you figure that one out. It's going to be a little bit more of a complicated factoring, but it works the same way. So talking about number of intercepts and turning points for a polynomial. So a polynomial of degree n will have at most n x-intercepts and at most n minus 1 turning points. So let's think about quadratic and cubic functions. So I'm just going to draw a random quadratic function. Okay, remember it's a parabola. Our n for a quadratic, our exponent or our degree is 2. So it can have at most 2 intercepts. So there's an example that has 2. An example that has 1 is if it's just sitting on that x-axis. Or it could have 0 by just floating up here in the middle of nowhere. And at most n minus 1 turning points, well, 2 minus 1 is 1, and they all have 1 turning point. If we think about a cubic function, remember with a cubic function, our degree is 3. So we could have a nice basic cubic function that might have 1 intercept. We also could have a cubic function that looks a little bit more like this, where we have 3. So there are different ways, but you cannot draw a cubic function to have more than 3 intercepts. And at most n minus 1 turning points, well, this first one doesn't really have a turning point because it keeps increasing the whole time. But this one has 2 turning points. So we can show that it has at most 2 turning points. So without graphing, let's determine the maximum number of x-intercepts and turning points for each function. So we're going to find our leading term. And in this case, our leading term is our negative 3x to the 10th. So our n in this case is 10. So remember, we can have at most n intercepts. So we could have 10 intercepts. And then n minus 1 turning points, we could have 9 turning points. All right, let's do the same thing for the next function. Find our leading term. In this case, it's not in standard form or in that descending form, but I can find that my leading term would be 14x to the 12th. That means our n is 14, so we could have 14 intercepts, and we could have up to 13 turning points. Now let's go the other way. Determine the least possible degree of the polynomial function shown. So first, let's talk about intercepts. We have 2 x-intercepts here, and then we have 2 turning points. We can't just look at one or the other because look, this would be saying that we could have a degree of 2, but this is saying we can't have a degree of 2 because n minus 1, the degree has to be at least 1 more than the turning points. So this is telling us our minimum is a degree of 3.